Good day, this is Jim Pytel from Columbia Gorge Community College Renewable Energy Technology Program. This is RET 120 Hydraulics. Today, by popular demand, I'm going to do a regenerative extension example using what we've just learned in our last lecture. You should be able to follow along at least, and at the end of this video, you should be able to do something very similar to this. Okay, so here is the big boy heavy hitter. This is a 6-inch cap. It's 18 inches long, and its rod diameter is 2.5 inches. Okay, and we want to go ahead and figure this thing out. How does it work? We want to figure out how much force it exerts in normal extension, how long it takes to extend and retract, the force at retraction, and then we're going to find that there's a very big performance flaw because it is so big. Because let's say our pump is limited to a flow rate of half a gallon per minute, and we're going to see that it takes a long time to extend this thing. So what we're going to try to do is hook it up in a regenerative extension mode and see if we can save ourselves some time. Okay, so let's go ahead and take this thing apart piece by piece. First thing to do is I would figure out the area of the cap. Area of a circle is pi over 4d squared. In this particular case, it's 6 inches. So pi over 4, 6 squared is going to give us a value of 28.27 inches squared. Since we're right there, let's figure out the area of the rod end. But what's happening, what's in the way is the rod. Okay? So let's figure out the area of the rod. Because if you look at this side right here, it's the area of the cap minus the area of the rod. The functional area is smaller in this annular ring because the area of the rod is removed. Okay, so let's figure out first off the area of the rod. Okay, so the area of the rod, pi over 4, 2.5 squared. It's going to give us a value 4.91 inches squared. 3, so area of the rod end going to be area of the cap minus area of the rod. So 28.27 minus 4.91, 23.36 inches squared. Okay, so now since we are looking for time for extension, we're going to have to go ahead and figure out how long it takes to fill up this space right back here. And at full extension, meaning our cylinder has bottomed out at the rod end, means it's traveled all this way. It's a cylinder with this functional area with a diameter of 6 that's 18 inches long. So volume of the cap is a cylinder, pi over 4 d squared h. But we've already figured out that area. That's the area of the cap. Area of the cap times its height. So 28.27 times 18 is going to give us a volume of 508.9 inches cubed. Okay? Since we are working in units of gallons, let's go ahead straight up convert this to gallons. So how do you convert? You can always multiply by 1. What is the conversion that we want? We want gallons. 1 gallon. We want to get rid of cubic inches. 231 cubic inches. So what we want up top, what we don't want at the bottom, the don't wants cross out, and we're left with gallons. That should give us 2.203 gallons. Okay, since we're right here, let's figure out the volume of the rod end at full retraction. So the volume of rod end at full retraction, if you can imagine, now this thing is all the way back. It is also a cylinder, but it has a cylinder removed out of the center of it. So it's a cylinder all the way back, but it has this volume removed out of the center. So what we have to do is take the, we got to figure out basically the volume of the rod end. Oh, first off, volume of the cap, and it's minus volume of the rod. This is the hard way to do it. So the volume rod end equals volume cap minus volume rod. What's the volume of the rod? Volume rod, this is the hard way. I'll show you an easier way. So volume of the rod, it's the area of the rod times the height. We already figured that out. Is 4.91 inches is the area of the rod times 18. It's going to give us a value of 88.3 inches cubed. So 508 minus 88.38 is going to give us a value of 420.5 cubic inches. Convert that to gallons, 231. So that's cubic inches. Gallon should give us a value of 1.82 gallons. So that's the hard way. So that, by the way, is volume rod end. There's a quicker way of doing this. If I've already figured out the area of the rod end right here, I've already figured out this functional area right there. That's already in squared inches, and all we do is just push it down 18 inches. It makes the cylindrical volume with that cylinder removed already. Okay, so here's the short way, quick and easy way to do this thing is volume rod end, area rod end times height. So what's the area of the rod end? 23.36 times 18. What do you get? 420.5 cubic inches, which we all know is 1.82 gallons. So hard way, easy way of figuring out the volume of the rod end at full retraction. Okay, so now that we've got our values right there, let's go ahead and figure out how long it takes to extend this thing. So time for extension, and our flow rate is 0.5 gallons per minute. This could also be rewritten gallons per minute. If you think about that, that is volume divided by time. If we want to figure out time, if we want a unit of time, and we've got a unit of volume, i.e. the volume of the cap end, how do we get time using flow rate? Well, if flow rate is volume per time, all we do is divide by our flow rate, Q, because that is volume divided by time. And what do we get? Because of this special arrangement here, time goes up here. Units of volume cancel out, and you're left with time. Okay? So, long story short, what you're going to do to get time for extension, take your volume, divide by flow rate, and make sure the volume is in the correct units, because our flow rate is in gallons per minute. Our volume should also be in gallons, and that's why we did that conversion earlier. And what are we going to get? Well, the time rate for the flow rate is in minutes. Okay, so we're going to get an answer of minutes. Typically we'll want seconds. We'll just go ahead and convert that later. Okay, so volume of our cap end for extension, because again, that's how long it takes to fill up this space right here. So the volume was 2.203 gallons with a flow rate of 0.5 gallons per minute. These guys cross out. We're left with a unit of time. What is that time? 4.406 minutes, which we all know minutes is 60 seconds, 264.4 seconds. Look how long it takes to extend that thing. So no wonder we want to go ahead and move ourselves to a regenerative extension system. Okay, so keep this number in mind right here, 264.4. And we're going to go ahead and see how a regenerative extension might save us some time. While we're here, let's go ahead and figure out force at extension in normal extension mode. Okay, force at extension in normal mode. Force is equal to pressure times area. Let's say we have a pressure of 1,000 psi. So 1,000 pounds per square inch times our area of 28.27 inches squared. Inches squared. It's going to give us a force of extension of 28,270 pounds, sufficient amount of force. Okay, so we're going to have to go on to the next page here. So 8. So let's say we're still in normal mode. We want to go ahead and figure out the time it takes for normal retraction. Normal retraction. Again, what's happening here is, so normal extension, we had P to T. Normal retraction, P to T this side. So pressurized flow is entering our cap end, and it's trying to, our rod end. It's trying to fill up that cylinder with the cylinder removed. So one would expect our retraction time to be a lot shorter than our extension time of 264, which we just figured out. Okay. Conversely, we would also expect our retraction force to be significantly weaker, because if we're still limited to 1,000 psi, we've got a smaller area because the area of the rod is removed. Okay, so let's go ahead and see if that is true. So what volume do we have to fill up in normal retraction? Well, we have to fill up the volume of the rod end, which we already determined right here is, actually that was a highlighter. I thought that was a highlighter. That guy right there. So 1.82 gallons. So time retraction is equal to our volume divided by our flow rate. Our volume is 1.82 gallons. Flow rate is 0.5 gallons per minute. Gallons crosses out. We get 3.64 minutes, which is 218.4 seconds. Okay, so we are absolutely correct. It takes a little bit shorter time to retract this thing because it's a smaller volume. Okay, now let me pose this following conceptual question to you. Would this thing retract faster or slower if we kept everything the same but increased the rod diameter? And the answer is it should retract faster, because think about this. Certain volume, 1.82 gallons, but if we increase the rod diameter now to less volume to fill up. Okay, so at a flow rate of 0.5 gallons per minute, you can fill this tinier space up faster. Okay, so let's go ahead while we're here. What is the force at at retraction, because we're going to go into what's the difference here. So retraction, force at retraction, this again is pressure times area. What is our functional area now? Our functional area is the annular ring, which is a smaller area. So let's go ahead and see if that is less force. Okay, so at 1,000 psi times our functional area of 23.36, which is again was our functional area of our rod. right here gives a force 23,360 pounds, which is confirming our suspicion that it is slightly weaker than at extension. Okay? So now, here comes the fun part. Time for regenerative extension. What is regenerative extension? Typically, to extend this rod, I put pressure here, and I dump this to tank. What if I did the following? I hooked pressure to both sides. One's immediate incorrect answer is that the cylinder would do nothing because there is a pressure balance on opposite sides. Equal pressure on the cap and the rod end. And that's absolutely true. There is equal pressure, but there is a force imbalance, okay? So it's not equal forces, it's equal pressure. Why is it not equal forces? Well, because you've got 1,000 psi acting on this side this way, and you've got 1,000 psi acting on this side this way, but it's only this area. So these guys are pushing against each other. Who wins? This guy, because the area imbalance right there. What is that area? That is the area of the rod, okay? So what's happening? This thing will extend when pressure is hooked to both sides of the rod and the cap, okay? So this is known as regenerative extension. We want to figure out, in this particular case here, the time to extend it. Well, what's neat about this is, where is, as this thing extends, we've already figured out it's going to extend. What's happening here? Well, it's pushing stuff out of the rod end. Where is it going to? It's going in here. Oh my gosh, it's going back in here. So that's regenerative extension. The volume of the rod end is being pushed into the cap end. It wouldn't fully extend this way because there's a volume imbalance. We've already figured out the volume of the rod end is smaller than the volume of the cap end. So the pump only has to make up the difference. What is the difference? The rod, the area of the rod, okay? So, remember, we figured out the volume at full extension, volume at full retraction. The difference is this little spot right there. That's the only flow that the pump has to make up, because all of this in the cap end, in the rod end, is being shoved back into the cap end, and the pump only has to make up that tiny amount right there. Okay? So, how long does it take to go ahead and fill up this area? Well, there's the hard way and the easy way. You could do, what is the volume and the flow rate, and you're figuring out, okay, what is the volume difference there? You're like, okay, it's the volume of the cap minus the volume of the rod end. And you could say my volume on my cap end, 2.203 gallons, minus the volume of my rod end, 1.82 gallons. But you could also just say volume of the rod. If you've done the hard work right here, 88.38 cubic inches, excuse me. Either way, you're going to come up with 3.83 gallons. Okay, that is what the pump needs to make up. So, time for regenerative extension. Volume 3.83 gallons divided by our flow rate of 0.5 gallons per minute. Gallons crosses out. What do you get there? You get 0.766 minutes, which is 45.9 seconds. Dig? Sufficiently faster than our earlier extension time of 264 seconds. Now there is a trade-off here. We can't get something for nothing. What is the trade-off? Number 11 here is, what is the force for extension in regenerative mode. Because again, we've already figured out that yes, there's 1,000 psi acting on this side, but there is also 1,000 psi acting on that side. So there's a force imbalance. Equal pressures, force imbalance. What is the functional area? Well, if these guys were going against each other, running straight on into each other, the only survivor is that guy going that way. Okay? So what is that? That's the area of the rod. Area of the rod. So my force is equal to pressure times area. Area of the rod times pressure. Area of the rod was 4.909 inches squared times a pressure of 1,000 psi. So my extension force in regenerative extension is 4,909 pounds, significantly weaker than our earlier extension of 28,270 pounds. Okay, so there is a bit of trade-off. Okay, so we have just basically taken this problem from the beginning to the end. And so somebody say, well, why aren't you doing regenerative retraction? Well, there is no such thing as regenerative retraction because, again, if we hook pressure to both sides, it's going to extend. We've already figured that out because of the area imbalance. There is no such thing as regenerative retraction yet. You might be the person that invents it. Okay, so you should be able to do a problem of this difficulty without difficulty.